Hello YouTube, RJ. Welcome back to the lab. Hope everybody had a Merry Christmas, and if you celebrate some other holiday, hope you had a happy holiday. And today we're going to do a video kind of continuing on some questions I had asked. This one was about how I do the circuit board layouts and then make my own circuit boards using the laser. And so we're going to start out much like we did with the faceplate piece. I've got a piece of single-sided, in this case, doesn't mean you can't do double-sided boards, but this is a single-side circuit board, and I've sprayed, just used some flat black paint. Don't think it really makes a big difference what you use paint-wise. It's just spray enamel. This happens to be what I tend to use. Spray the flat paint on there. You've got to let this particularly get, totally dry. A couple days probably is a good idea at least, because you're going to put this in an etchant to take the copper off, and if it's not totally dry, it'll get up under it and it'll etch our copper where we don't want to, and the paint will come off, and it's a mess. You ruin your board. So usually I had this already laid around. This thing has probably been dry for 4 months. I usually spray a couple of these boards, put them in my bin that has the circuit boards, and that way I got a couple ready to go. If I have an idea or want to make a board, I don't have to sit around for days waiting on it to dry. So anyway, this is it. Just get you a nice, smooth, even, maybe run over the board with a little 400 sandpaper, 600 sandpaper, very lightly, no pressure. Clean it off real well. Let that dry. I use alcohol. Spray you a nice light coat. Give it 30 seconds. Put you another light coat, maybe 30, 45 seconds. Put you another decent coat on it and leave it alone. Let it dry, and you're ready to go. Now we got to go design a circuit board. I'm going to go ahead and use one I've already done. I don't want to bore you guys sitting there watching me run traces and such. I'm just going to do the one that started this, the little circuit board I created for the meter calibration on the high voltage power supply. We're just going to redo that board. I'm going to walk you through it. Let's jump over the computer. See you there. All right, we're over on the computer and we're in dip trace. And this is the little circuit board I laid out for the meter calibration high voltage power supply. And it's not exactly the board I ended up with, but it was the first one I laid out. But we're looking at the board. We're on the top and we see all of our silk screen and such, but the traces are all actually on the bottom. So what we need to do is we need to get this into a image, if you will, so I can put it on the laser and actually cut the paint off the board where I want it to take the copper away. So what I do is, if I go over to File, Preview, again, this is a dip trace. Your software could be different, but you'll have a preview somewhere. I can go in and choose, which side I want to look at. In this case, we're on the bottom. We're worried about the traces. I can go in and also tell it what I want to see and what I don't want to see. We're fine. You definitely want board. We need this board, the board outline, because we're going to use that to verify the size and size everything. So now in here, I have some options that you may or may not have. I use print and black only, but you have negative and mirror. And in this case, we need both. And here's why. Since we're looking at this board and we're looking at the bottom, we're x-raying through the board. If you rotate the board around and cut it on the laser, you'll be mirrored image to what this looks like. So what you want to do is to overcome that is to go ahead and mirror it now. That way when we cut it, this will now be on the top, even though it's the bottom of the board. When we rotate the board upside down, everything will be correct. So that's number one. If you don't have that in your PCB software, just bring the image into Paint Shop, Photoshop, whatever you use for doing editing photos, and do it in there. The other thing we've got to do is negative. And that's because the laser cuts where there's black and ignores where there's white. We don't want to cut where we're black because that would remove the paint off of where we want the copper to stay. And we want the opposite. We want the laser to remove the paint off of the copper we want to go away, thereby allowing the etchant to get to that copper and take it off the board. So we go negative. Again, you can do this in your software you edit photos in if you need to, but I have it right here. My software also allows me, dip trace that is, allows me to save it out as an image. If you don't have this, I'll show you another way to do it. So let's hit save. We're going to save it as a PNG image. We're going to crank it up. You want about 600 DPI. So let's save that. We'll save that out and we're good. We've got an image to work with. Now, what if you don't have this ability in your software? If that's the case, what you want to do is you want to open up a snipping tool or Snagit or some screen capture software and go ahead and capture, making sure you get right to the edge of the board. So you're only getting the board. because that's how you get your dimensions to know that you have the right size. So you would line it up, you would do like this. This would be the image that you would then save out. Try to make it at least 600, make it 600 dpi if you can do that. Whatever you need to do to get a good quality image saved. Now, once we've got the image, we can close out our PCB software. We're done there. And then okay, we're on the laptop in the craft room. We're going to open up Lightburn, our laser software. What we're going to do is we're going to go over here to the camera. I have to do this to connect it and get an image. There's our little black circuit board. We're going to go over here and import from our USB key. And you're going to notice that it's way bigger than you expected. And if you look up here, you'll see it thinks it's 404.318. No, we know what size it is. The circuit board was 80 millimeters by 40 millimeters. And that's exactly what we want. That's why you need to know what size your board is. So now we know the image is sized properly, we can put it on the board here. Zoom in a little more. And kind of line it up into the corner where the board is going to be. Just roughly, because it won't be perfect. We'll have to move it around a little bit in the laser machine to get it all lined up. So at this point, we've got to go over and set up our settings. Let's do this. Let's do 2000. I'm going to do 75% because I want the laser to cut into the copper some, and that'll shorten how long it takes to etch the board if we actually remove some of the copper, not just the paint. We want to do 600 dpi. This all looks good. We can hit OK. We can take a look at the preview and see what it thinks it's going to do here. It's what it's going to cut. Everything black is going to get cut off. So all we're going to have is copper everywhere it's black, black paint where you see the white, and that's exactly what we want. We want the black paint to protect our copper, and we want it off of here so the copper can be etched. So this looks good. Looks like it's going to be about 37 minutes to do this. We could probably bump the speed up some and do it a lot quicker. I'm pretty sure I could do 3,000. Let's do 100% constant power. That will probably pretty well take most of the copper off, I would guess. So let's see, how long is it going to take now? Now it's going to take me 25 minutes. The big thing now is we need to go ahead and home the laser and frame it out. And I'm going to grab the handheld camera, if you'll give me just a second, and I'll show you what we're doing, so you can see. Okay, here's what happens. When I hit the frame button, it's going to come down and show me where it thinks it's going to be doing its work. So let's let it run down here. And let's try to watch for the little red dot. See that that's not right. So what we want to do, we want to bring the corner of this over to the red dot. Right at the corner. This. And then we're going to run it and watch if it runs along the edge, whether this side needs to go up or down. What we need to do to line it up the way we want it. So let's see here. It's not too bad. Kind of looks like this corner could just bump up a little. So let me bump it up just a little. Let's see how that looks. Needs to come back. That looks pretty good right there. So now that we've got it all done, we'll close up the laser, our protection. Get up here where we can see. And we will start it. So literally it's just a matter of clicking start. And it should start doing its thing. We probably won't be able to see much for a little bit till it gets some cutting done. You can kind of make out the line there at the bottom where it's cutting the paint off. So we'll let that rip. I'll come back and we'll take a look at what we ended up with, and then we'll go from there. Okay, we're on the bench, the laser finished. All I've done is took it out. I took a little bit of Dawn dishwashing liquid soap and a little bit of water, just wiped it with a paper towel real lightly. So take some of the dust from the, the laser burning the paint off and such. And if you look, there is still copper there. It may not look like it. I'll get her up here a little closer. Maybe I'll get the light right. You can see there's still copper there. It's very thin though. The laser takes a lot of it off. The nice part about that is my etchant doesn't have to do as much work. It happens a lot quicker and don't use up my chemical as quick. For chemical, I use ammonium persulfate. And the reason I don't use ferrous chloride is because it is so nasty and stains everything, makes, this just, it's a messy chemical. This works very well, much cleaner to deal with, doesn't stain everything. It's still bad chemical, you got to be careful about disposing it. But the other thing is I can recharge it with a little extra and just keep using the same chemical over and over again instead of having to get rid of it every time. So anyway, there's nothing to it at this point. You can see the paint is still on everywhere we wanted. You can see, again, the resolution is quite good on the board. I'm gonna get it right up there. Hopefully it'll stay in focus enough. You can see how clear and crisp everything is. I've had a question about, I got to ask, someone wanted to know if I ever used the toner transfer method where you do the sheet and you print and you put it on and iron it and use that. Yes, I have. And they want to know, how does it compare to this? It doesn't. This makes a much cleaner, higher resolution pattern. You don't get where the toner doesn't stick down well in little spots that get damaged that you have to touch up afterwards. The paint is there, it's dry, it's on there good. The laser takes it off crisp and clean where you want it. So it works very well. So what I'm gonna do is, what I typically do is just take me a pair of clamps. I keep my chemical in a sealed cereal, one of these snap-on, almost like vacuum cereal containers. And they're tall, they hold the material well. And now what I'm gonna do is just take this, drop it down in there like this, and I'll let it do its thing. And I don't have a little pump, I don't have a little heater, I don't really need that. I don't tend to end up taking a lot of copper off because the laser takes so much of it off. I'll come in and stir it every couple minutes for a while, looking at it each time. And other than that, I normally do wear gloves. Don't know why I didn't put them on. I guess I got going on filming. I'll go rinse my hands off. But I just agitate it a little bit every couple minutes and look at it and check it. And you can tell when the last of the copper's coming off. It's, depending on how strong I mix it, it doesn't take long at all. It can be if it's fresh and I've just made up some, it'll take it off in a couple of minutes. If it's been a while, it might take 15 minutes, 20 minutes to get it off, but it does fine. So I'll come back in a few minutes. We'll take a look at it when it's done. Sometimes I cut the board out before I etch it. Usually I'll etch it and then just cut the board out on my little table saw thing that I'm sure you've seen the video where I finally found something that I like for cutting circuit boards. It's a little Harbor Freight table saw with a diamond little tiny 4-inch wheel that works great. So anyway, we'll just let this etch and let you see the finished product. We'll see you in a couple minutes. Okay, we're back. I pulled it out of the etch. You can clearly see, quite sure that it's etched all the copper off cleanly. And you can probably see just how high a resolution and how clean the edges are and such. So now the next step is we need to get the paint off. And the best thing for that actually is mech, which, you need to be a little careful with mech. Mech will blind you. You do not want to get mech in your eye. Going to use my little Q-tips, my little foam Q-tips, put a little acetone on the paint of the traces so we can get that working on it. And it will. Ooh, I did it now, didn't I? That was a oops. Takes a minute. It's getting it right off there. You can see the paint coming off the traces. And I'm not going to be using this board, as you know. I'm just doing this to show y'all how to make the boards, how I do it. Going to take all this paint right off over here. And I don't care about fighting to get all this paint off over here for what I want to show you. Okay, once you get your paint off your traces, cleaned up good, where you got your bare, clean copper, looking nice. We want to protect this copper. We want to make it where it'll solder good. So what I always do is I tin them with a little bit of tin. Oh, sorry, it's taking me a minute to get it clean. I use my 421A MG Chemicals 421A liquid tin. Shake it up good. Get the tin floating around the emulsion good. Get it open. I'm gonna have to grab some more Q-tips. So what I'm gonna do is just wet my Q-tip down good with the chemical. Start rubbing it on my copper, and you'll see immediately it'll start turning tin colored. It'll put a tin coating on there. And how thick a coating depends on how wet you get it and how long you leave it on there. It'll instantly put a light layer on there. But if you want to get a good layer on there, you want to get it on, let it set a little bit, and keep rubbing a little fresh on it. And it'll just keep layering that tin heavier and heavier. And you know, it doesn't have to be super heavy or anything. It just you're wanting it to be where it'll solder too good and it won't corrode. So, you know, this is good enough. This board is not going to be used, but you get the hint. I usually let it sit there for about 10 minutes, rubbing it around a little bit every so often, and it gets a little heavier tin plating on it. But you can see I'm going to wipe it here in a second with a new clean paper towel, and I'll let y'all take a good look. All right, and you should be able to see there a nice circuit board with tin traces, and it's just a matter of drilling the holes now for this single-sided circuit board, cutting it out, and you've got a nice circuit board. That simple. So, hey, hope that was entertaining. Hope it was educational. Hope I showed you exactly what you wanted to know about how I'm doing this with laser. You can see how high a resolution it is. You don't have any traces peeling up, and you don't have the rough edges you do like the toner transfer technique. Anyway, it works really well for me, and it is possible to do double-sided boards. I've done it before. What I usually do is if you mark 4 spots equally spaced on the board that you can drill, and then use it as a locator, so you can do one side of the board and flip it and locate it precisely so that your holes line up on both sides. You can do the exact same thing with the laser on the other side, etch both sides, and when you drill, you'll drill through this side into that side. And if you need vias, you just do a little pad, you drill a circle, drill a small hole, take a small piece of copper wire in there, solder both sides, you got a via. I've done some pretty elaborate boards doing this kind of technique. Hope you see that, you know, it is kind of a handy way to make boards. And so I hope you enjoyed this. Thanks for hanging out with me. But most of all, I hope to see you in the next video.